Okay, so today is our last chapter or section of the year, and it's 7.7, Basics of Probability. This will give you a little intro into probability and a little of the topics that we actually cover in AP Stats for those that take that next year in the near future. So just as we move on, I want you to think about the following scenarios and questions. Imagine we have a spinner that has 5 equal sectors, colored blue, yellow, red, green, and black. I want you to think about, after spinning the spinner, what are your chances of landing on red, and what are your chances of not landing on blue? But before we go back up and do that problem, let's look at a couple definitions. So the first definition is an experiment. An experiment is a situation involving change that leads to results called outcomes. Okay, so we're going to do an experiment, something's going to happen, and then we're going to end up with an outcome. The experiment is spinning the spinner in this case. We have our outcomes, and that's just the result of one trial. In this experiment, I have 5 different outcomes. I have the 5 different colors. An event, is one or more of those outcomes, such as the event can be landing on red. So if I want to talk about what's the probability of an event, I would talk about what's the probability of landing on red would be one of those. Probability, this is an important part here. It's the measure of how likely an event is. Your probability, which is denoted by P, is always between 0 and 1. And really what that's meaning is 0% and 100%. And the way you find your probability is you're going to take the number of ways the event that you want to happen, or in this case we'll call event A, can occur, over all the possible different outcomes that could happen. And our next and last vocab word here is complement. A complement is the set of all outcomes not included in the event. So if I ever wanted to find the probability of a complement, and a lot of times you will see that denoted with a little tick mark up there. That's just going to be equal to 1 minus the probability of the event happening. You can also see complement denoted as a little C up above the name there, but it kind of goes back and forth in different spots throughout the time. All right, so let's go up and see these 2 examples. After spinning the spinner, what are the chances of landing on red? There are 5 of those outcomes, right? So we're going to say, what's the probability of landing on red? This is our notation. The P is standing for probability. The event I put inside is what we want to happen. Well, there's only one way to land on red out of 5. So I could leave it as 1/5, or I could say 0.2. Either of those are fine. What are the chances of not landing on blue? The probability of not landing on blue now in this case it's pretty easy because there's 4 other colors. So it's 4/5. Or you could look at it being 1 minus the probability of blue, which is 1 minus 1/5, which is 4/5. Again, that's just another way you could do this. You don't have to do it that way. You could have just gone straight ahead and found the 4/5 for knowing that there's 4 other things that could happen. As we continue here, let's talk about another question. We're going to talk about sample space. So sample space is all the possible things that could happen. You list out all those outcomes. So they want us to answer the question, what is the sample space of spinning the spinner and flipping a fair coin? So we're going to do 2 different things. If we think about this, we usually put our sample space inside brackets. So let's start with the spinner. I could get a blue on the spinner and a heads, or I could get a blue and tails. And we can go through that for all of our colors. Then we got yellow. I could get yellow and a heads. I could get yellow and tails. Then we got red. Red heads, red tails. We're not going through 10 of these because we have the 5 colors and we got our next color here. And then finally we finish off with black. Okay, so those are our 10 different outcomes. And if you think about it, that kind of makes sense that there's 10 because we'd call the spinner and the coin independent events. So there's 5 ways for the spinner. 2 ways for the coin should give me 10 different events. So what is the probability that you land on yellow or get a tail on the coin flip? Let's think about that. Up here, how many ways involve getting a yellow? So we got these 2 yellows. Okay, how many of them involve a tail on the coin flip? So this is a tail. We already counted this one. We don't need to do it again. There, there, and there. So what we see is there's 1, 2, 3, 4, 5, 6 of these, of 10 different things that could happen. So we end up with 6 over 10, 3/5 or 0.6. Okay, those all follow in our different spots there. So what we did there was talk about the probability of 2 events. Okay, 2 different things that were happening, one then the other. So for an event, E and F, let's say we have those 2 events. If I want to find the probability that E or F occur, sometimes you may see or, sometimes you may see this, the union sign. What I do is I add the probability of the first event plus the probability of the second event, but then I need to take away the probability of both them happening, and that's your intersection. So if we go up to that last example, okay, there was 2 out of 10 for the yellow, there was 5 out of 10 for the tails, but there was 1 overlapping. So that ends up being 6 over 10 as well. Now, we may run into some events that are called mutually exclusive events. These are events that cannot occur at the same time. If events are mutually exclusive, we do not need to worry about the intersection as there is none. Okay, so if I'm talking about rolling a die, and my events are rolling a 1 and rolling an even number. Okay, well, there's no way to roll a 1 and an even number at the same time. So their intersection would have nothing there. So a lot of our questions of probability will deal with cards. Okay, so when I look at a deck of cards, I've provided a picture over here for you. So if we do run into any card problems, feel free to use that. And again, there's cards going from ace to king in each of the 4 suits, the clubs, diamonds, hearts, and spades. So that's 13 cards per suit, and then half are red and half are black. So the first question is, what is the probability the card is red or a king? So the first thing you want to think about, can they both happen? Can I get a red king? And yes, I can. So we're going to be using that intersection part. It's going to be part of it. So the probability of a red or king is going to be equal to the probability I get a red plus the probability of a king minus the probability of a red and a king. So we got to think about how many reds. Well, that's half the deck. And what I like to do is keep it over 52 at all times and then simplify at the end. So 26 out of 52 are red. How many kings? Well, you go down the last category. There's 4 kings out of the 52. And then 2 of those kings are red. So I need to take away 2 of the 52. So we got 30 plus 2 or minus 2, that's 28. Okay, and that will simplify to us 7 over 13. So 7 over 13, or if you want to write that as a decimal, okay, that's about 0.54. So about 54% of the time, when you pick a card out of a deck, you're going to pick a red or a king, which makes sense. If reds are half the deck, and then there's a couple kings that are black, then we do have a shot to go a little higher. Second question is, the card is a club or a diamond. Those do not overlap, so we call these mutually exclusive, sometimes called disjoint instead. Okay, and so we're looking at the probability of a club or a diamond. And again, you can write or the union sign. Well, clubs, there's 13 of them. Diamonds, there's also 13. So what that really does is gives us half the deck, or 50% chance of getting one or those other. Okay, so cards are a pretty common problem you'll see. The other one is the sum of dice. So suppose 2 fair dice are rolled, 1 red and 1 blue. And the reason I'm pointing that out is, so we know which dice is which. Find the probability that the blue die shows a 5, or the sum of the 2 dice is 11 or 12. So we gotta look at the probability. Blue equals 5, or blue plus red equals 11 or 12. So let's look at this. The probability that blue is 5. Okay, so we'll call this blue dice and the red dice. Well, there are all the possible outcomes. And these are what we could see here. So we know though that blue is going to be a 5 1 out of 6 times. Okay, so we know that this is going to be, let me move this real quick. One over 6. Plus, what's the probability that we sum to 11 or 12? So you could your heads to be like 5 and 6, 6 and 5, 6 and 6. So you could think about it that way. Or you can go to this little table we have here. What you see is your red and your blue die, adding them together. So 1 and 1 make 2, 1 and 3 make 4, and so forth. Okay, so we see that there is 3 ways in which we can have 11 or 12 out of 36 ways. Because there's 6 options here, 6 options there. So we see that that's 3 out of 36 for the blue plus red equals 11. And now, can they overlap at all? Well, if you see, here is one way where the blue die was a 5. So that is 1 out of the 36. So 1 out of 6 is really 6 out of 36. That makes it 9 out of 36, 8 out of 36. Okay, our 2 ninths, which is 0.2 repeating. And the last one is the sum is at least 9. So we're just talking about what's the probability that the sum is greater than or equal to 9. So it's just one event. So I want to look at this chart and just figure out at least 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 36, or 5 out of 18. 36, not 35, sorry. Which is 0.278. Again, that's about, not exact. So this is a really nice chart. Again, it's just you're listing your one die over here, your other die over here, and you're adding to get those rest of those spots. And those are your 36 different outcomes that you can have. Okay, so we're going to do this is our last little bit of this chapter. We got the odds and binomial experiment to the left. Okay, so odds, you've probably heard those before. You know, if you talk about sports, the odds of a team winning or the odds of a certain horse race outcome, you know, it's always expressing the probability of the event happening to it not happening. Okay, and we also do this as the probability of the event happening over the probability of the event not happening. So a marble is drawn at random from a bowl containing 6 green, 4 blue, and 8 yellow marbles. Find the probability of the event, find the odds in favor of a yellow marble being drawn. So our event is yellow. We have 8 yellows, so that makes it 8 that we want. And then we have 6 green and 4 blue, so that gives us a total of 18 marbles, which simplifies to 4 ninths. Then for not being yellow, you could either do 1 minus 8 over 18, which is 10 over 18, 5 ninths. Or you could have said, hey, well, there's 10 that aren't yellow. So we express this as the probability of the event happening, 4 over 9, over not happening, 5 over 9. Well, we multiply by the reciprocal. That is 4 over 5, or you can write it as 4 to 5. And really what you're saying is the odds in favor of yellow being drawn is 4 to 5. 4 yellows to 5 non-yellows. The last problem here, and this one plays one of the biggest roles in AP Stats, is the binomial experiment. Okay, a binomial experiment consists of repeated trials where there's only 2 outcomes that can happen, and that's the part that students struggle with. There may be more than 2 outcomes, but it's what you are looking at. So if I say rolling a die, and there are 6 outcomes there, 1 through 6. But if I say my event is rolling a 5, well, rolling a 5 is a success. The other ones are all failures. Or if I say the probability of rolling an even, 2, 4, and 6 are all successes. 1, 3, 5 would all be failures. We use this formula here to find the probability of obtaining exactly our successes and then trials. Okay, so how many successes I want and how many trials. And we have this part, that's your NCR. How many different ways can it happen? You know, if I'm doing 5 dice rolls, you know, maybe I get a 5 on the first, 5, not a 5, not a 5, 5. Or a 5, not, and then 5. You know, the different ways it could happen. That's the probability of success raised to how many successes. The probability of failure raised to how many failures we're going to have. So again, P, probability of success in one trial. 1 minus P, probability of failure. And the number of trials are the number of successes. Okay. So an experiment consists of rolling a die 12 times. So that right there is going to be your N. Find the probability of that in exactly 3 rolls. Okay, the result is a 5. So in exactly 3 of the rolls, the result is a 5. So we want exactly 3 successes. There's your R. We're looking at the result is a 5. Okay, so the probability of rolling a 5 is 1/6, which means the probability not of 5 would be 5/6. Okay. So you got 12, choose 3. And you could write it this way, or you could write it 12, choose 3, whichever way you like. Probability of success, 1/6. I want 3 successes. Probability not a success is 5/6. Well, it would be N minus R. So that'd be 9, the other rolls that we still have left. So go to the calculator to figure this out. So again, go to find your NCR option. Minus 12, choose 3. And then we got 1/6 to the 3rd. And then we got 5/6 to the 9th. 5 6 to the 9th. Sorry, real quick. Okay, and you end up with 0.197. Okay, just be careful that you do enter everything in correctly so you get out the right outcome there. Okay, going back up to the top, an experiment consists of rolling die 12 times. Find the probability that exactly 8 rolls. So here's our new R. The result is not a 5. Okay. Now, we got to be careful with this. This is how many times we want 8 of these. We want 8 of this one, then we'd only want 4 of that. Okay, so 12 choose 8. Then I have 5, 6, because that's considered a success now. And I want 8 of those, and then 1, 6 to the leftovers, which should be the 4. Now, in a problem like this, you could have those flipped, but you just got to make sure that the corresponding ones are in the right spot. So again, let's figure out what that is. So NCR, 12, and then 8. We got 5, 6 to the 8th, and 1, 6 to the 4th. And we find that to be 0.0888. Okay, not too worried about decimal places. When you are doing MathXL, just make sure you go to the number that they ask for. And that finishes up our rest of the year. And we just have some review and some practice to get ready for your quiz.